1, 4, 7, 10, 13, 16, 19. Friends, do you know what is this sequence of numbers known as? That's right, it's called an arithmetic progression. Because if you take the difference of any two consecutive numbers, can you see that the difference is constant? It's 3 in this case. And arithmetic progression is going to be the topic of this video. In this video, we are going to be practicing different types of questions on this topic. And I'm sure after watching this video, you'll find arithmetic progression really easy. And if you find this video useful, do hit the like button and share it out with your friends. And do check out my website, manochaacademy.com, to practice more questions on this topic. I'll put the link below. First, let's revise the basics of arithmetic progression, or it's known as AP in short. So here I have this sequence of numbers 1, 4, 7, 10, 13, 16, 19 and so on. Now why is this an arithmetic progression? Because if you take the difference of a term and the previous term, you'll see that the difference is constant. So can you see that 4 minus 1 is 3, 7 minus 4 is also 3, and here if you take 13 minus 10, 3, 19 minus 16 is also 3. So can you see that they have a common difference, and that common difference is denoted by the letter D, and it's 3 for this sequence, right? And the first term is denoted by the letter A. So now if we want to find the nth term in this AP, then we can express the nth term as Tn, or you can use the symbol An for it. And what is the formula for that? Tn equals A plus n minus 1 into D, where A is the first term, n is the term number that you want to find, and D is the common difference. So let's try out this formula. Let's say we want to find the 6th term in this AP. Okay, so we want to find T6, right? And what is that going to be? So using this formula, A, so we'll start with A. And what is the value of A? That's right, the first term, can you see? It's 1. So let's substitute that. And then since we are interested in the 6th term here, it's going to be, n is going to be 6 here, right? So we need to substitute 6 minus 1. And what is the common difference here? As we saw, the common difference was 3. So it's going to be multiplied by 3. And if you calculate this, what do you get? It's going to work out to be 1 plus 5 into 3, 1 plus 15, which is 16. So the 6th term of this AP is 16. And can you see? 1, 2, 3, 4, 5, 6th. So the formula, using the formula, we predicted the 6th term. So this formula Tn, or you can write it as An, gives you the expression for finding the nth term in the arithmetic progression. Okay. Now let me ask you, let's say we have numbers like this, 5, 4, 3, 2, 1. Okay. So do you think this is an arithmetic progression? That's right. This is also an arithmetic progression because if you take the difference of a term and the previous one, what is the common difference here? So if you take the difference between these two terms, can you see the difference is minus 1? And again, any other two terms you take, the difference is minus 1. So can you see that the common difference here is the same, it's minus 1. So this is also an AP. So an AP can be decreasing also like this. And how about this sequence? Let's say I write this sequence here, 3, 3, 3, 3, 3, and so on. So is this an AP? What do you think? That's right, this is also an AP. Again, apply the same concept. Can you see that the common difference between two consecutive terms here is 0, right? So the common difference, can you see here, is 0. So even this the same terms 3, 3, 3, 3 also form an arithmetic progression. Now let's practice some questions on arithmetic progressions. I would recommend you to pause the video here and go and get a pen and paper so that we can solve the questions together. So are you ready? Let's start with our first question. Show that the progression below is an AP. Find the next term of the AP. And here's the progression that we've been given. Now how do we solve this? So the trick is to show that this progression is an AP, we need to find the common difference between the terms. And we need to show that this common difference is constant, right? Because remember, in an AP, the common difference should be constant. But since the terms look a little complicated here, since there's square root 18, square root 50, first let's see if we can simplify each term. So we can write square root 18 as, so if we take, it's 9 into 2, right? So it's going to work out to be 3 root 2. Okay. And what will this term work out to be? So try it. It's going to be 5 root 2, right? And this term is going to be, so 98 is 49 into 2. So that's, if you take the square root of 49, so we have 7 root 2, right? So now the terms are simplified. So let's find the common difference between consecutive terms. So between this term and its previous term. So what is the difference going to work out to be? So if you subtract these two terms, what do you get? Right. So if you subtract it, it's going to be 2 root 2, right? So if you subtract these two, similarly, if you subtract these two, what are you going to get? It's again going to be 2 root 2, right? 7 root 2 minus 5 root 2. So can you see that the common difference is 2 root 2. So therefore we have proved that this is an arithmetic progression. This series is an AP. Okay. And now we need to find the next term of the AP. So what term will come after this? So that's pretty simple. To find that term, you just need to add the common difference to this term, right? So it's going to be 7 root 2 plus the common difference d, which is 2 root 2. So what is that term going to be? The next term is going to be 9 root 2. Okay. And if you want to write it in this form, so we need to take the 9 inside. So that's going to be 9 into 9 into 2. So the answer is going to be 1's root of 162, right? So that's the next term of this arithmetic progression. That's our answer here. Now let's try this question. Find A and B such that the numbers A, 9, B and 25 form an AP. So again, what's the key concept to use here? That since these numbers form an AP, the difference between a term and its previous term is going to be constant. So let's apply that here. So the difference between 9 and A is going to be 9 minus A, right? And that's going to be equal to the difference between B and 9. So B minus 9, right? And that's going to be equal to 25 minus B. Because we know that the difference is constant. It's a common difference. Okay. So now let's use this part and solve for B. So we have B minus 9 equals 25 minus B. Right. So if you solve that, it's going to be 2B equals 34. So B works out to be 34 by 2, which is 17. So we found the value of B. Now we can use this part, 9 minus A equals B minus 9, to easily find A. So let me write that down here. 9 minus A equals B minus 9, right? I'm using this part, and since we already have the value of B, so it's going to be 9 minus A equals 17 minus 9. So 9 minus A is equal to 8. And so basically we have, if you solve it, A is equal to 1. So there we found our answer. We've got the value of A and the value of B. And we use this important thing that the difference between two consecutive terms is constant. So 1, 9, 17 and 25 form an AP here. Can you see that the common difference is 8? Ready for the next question? Here it is. Find the 21st term of the AP minus 5, minus 5 by 2, 0, 5 by 2 and so on. Okay? And remember, to find the 21st term or the nth term, we need to use the formula Tn equals A plus n minus 1 into D. Remember that formula? Okay? And so what is the first term here? It's denoted by A, right? And A is going to be this term, minus 5. Now what is the common difference D? Now since we already know that this is an AP, we don't need to prove it's an AP. So we can take the difference of any two terms to find the common difference D. And let's see what do we get. So it's easy to take these two terms, 5 by 2 minus 0. So the common difference is basically 5 by 2, right? So we've got our D, the common difference here. Okay? And since we need to find the 21st term, so we need to find T21, or you can also denote it by A21. Okay? So that's going to be A plus, so we're going to substitute the value minus 5 here, plus n. So here n is going to be 21 minus 1 times the difference, 5 by 2. Okay? And if you work that out, so this is 21 minus 1, that's going to be 20 into 5 by 2. So we are going to get here minus 5 plus this is going to be 50. This works out to 50. So our 21st term is 45. That is our answer here. So here the main thing is to use this formula and correctly substitute the value of A, N and D to solve this question. Now let's look at this question. Sum of the 4th and 8th terms of an AP is 24 and the sum of its 6th and 10th terms is 44. Find the first 3 terms of the AP. So the trick to solving this is you look at the given conditions and you form your equations. Okay? So what are the conditions that we've been given? That the sum of the 4th term, so T4, plus T8, the 8th term, is given to us as 24. Okay, so that's our first condition. And now let's look at the other condition. We've been given that the sum of the 6th term, so T6, plus the 10th term, T10, is given to us as 44. Okay, so let's use our arithmetic progression formula for the terms and let's see what equations we can get from here. So let's start with the first one here. T4 plus T8 is 24. Now we are going to use the formula, remember, Tn equals A plus n minus 1 into D. Okay, so if you apply this formula, T4 is going to be A plus 3D, right? So we are doing it for this equation, plus we are going to get A plus 7D, and that's going to be equal to 24, right? And so if you simplify that, we get 2A plus 10D is 24. And further simplifying that, we get A plus 5D is equal to 12. Okay, so that's our first equation here. Okay, and now let's use the second condition, this one, and let's form the other equation. So it's going to be A plus 5D, right? So that is T6, and T10 is going to be A plus 9D, right? And that's given to us as 44. So let's add these up. We get 2A plus 14D is 44. So therefore you can write this as, the simplified form will be A plus 7D is 22. So this is our second equation here, right? And can you see that we have two linear equations here, 1 and 2, and we have two unknowns, two variables, right? A and D. So clearly you can see we have two linear equations in two variables. So you can solve them pretty easily, right? So I'm not going to show the solving of linear equations. You can do that. It's pretty easy. So if you solve them, we are going to get A as minus 13 and D is going to be 5, the common difference D. So on solving these two equations, equation 1 and 2, we get these values. And so now it's pretty easy to find the first three terms of the AP. So what will be the first three terms? So the first term obviously is going to be this one. The first term is minus 13, simply A, right? The first term. The second term is going to be A plus D, right? T2, right? So that's A plus D. So that's going to be minus 13 plus 5. So we have minus 8. And the third term is going to be A plus 2D, correct? And so what is that going to be? So we are going to get minus 3. So here we have solved the first three terms of the AP, minus 13, minus 8 and minus 3. Let's try this question. Find the middle term of the AP 213, 205, 197 and all the way up to 37. Okay. So this sequence that we've been given, the question says that it's an AP. Now if it's not given that it's an AP, then you first need to prove that it's an AP by checking the difference should be constant between the terms. So we don't need to do that, right? We can assume that it's an AP because it's been given. So what do we know about this AP? We know that the first term is 213. So this is A, right? So A is 213. Okay. And what is the difference, the common difference here? So it's going to be 205 minus 213, right? So that's going to be minus 8. Okay. And we need to find the middle term, but we don't know how many terms this AP has, right? So first we need to find the number of terms in the AP. Okay. So let's say the last term, this is the nth term of the AP. Okay. So let's say this is the nth term. So we can represent Tn. The nth term we know is 37. Okay. And what is the formula for the nth term? It's going to be A plus n minus 1 into D. Right. So now if we substitute these values, so 37 is going to be 213 plus n minus 1 into the difference minus 8, and so this is 37, right? And if you solve this, you'll get n, the number of terms of the AP as 23, right? So what do you think is going to be the middle term of this AP? Since the AP has 23 terms, the middle term is going to be, so to find the middle term, that's going to be 23 plus 1 by 2, right? So the 12th term is the middle term, right? And so how do we take out, find the middle term here? So we basically need to solve for T12, and that's again A plus n minus 1 into D. So that's going to be 213, and n minus 1 is going to be 11 into D. The difference is minus 8. Okay, and if you solve this, you will get T12 as 125. So that's our final answer. We found the middle term T12 is 125. Now let's look at this question. If m times the mth term of an AP is equal to n times the nth term and m is not equal to n, show that its m plus nth term is 0. Okay, so we need to show that the m plus nth term is 0. So first let's use the formula and write the terms that we are interested in. So the mth term we can express it as Tm is equal to a plus m minus 1, right, into d. And what will the nth term be? Same thing, just use that formula. Tn is going to be equal to a plus n minus 1, right? N minus 1 into d. Okay? And we are interested in the m plus nth term. Okay? So let's write that down also. So we know what term we are interested in. So Tm plus n is equal to a plus m plus n minus 1, right, into d. Okay, so that's the term we are interested in. Now let's see what have we been given. So we can form the equation on what's given to us in the question. So we've been given that m times the mth term is equal to n times the nth term. So let's write that down in symbol form. So we've been given m times the mth term, right, is equal to n times the nth term. Okay, so let's go ahead and substitute these formulas in this equation. So we'll get m times a plus m minus 1 into d is equal to n times a plus n minus 1 into d. Right? Okay. And let's multiply that out and rearrange that. So we'll get ma plus m into m minus 1 times d, and that's equal to na plus n into n minus 1 into d. Okay, that's pretty simple. And now let's group the a and d terms together. So we can write a into m minus n. So I'm bringing the na that side, plus we'll get m square minus m minus n square plus n, okay, into d, and that's equal to 0. So I brought all the terms on this side and we've grouped them together. So now let's see what we can do here. So can you see that we have a into m minus n here, plus you can group these together. So m square minus n square, so that's going to be, that's essentially m plus n into m minus n, right? And then we have this remaining term here, minus of m minus n into d equals 0. Okay, so we are just simply grouping the terms together and seeing what we can get in common here. So now can you see that the m minus n is in common, right? So let's take that out here. And we are going to get a plus, and what are we left with if you take m minus n common? It's going to be m plus n minus 1 into d equals 0, right? So just take a look at this. So you can compare this equation, the one we have here, right? Just by grouping this, we'll get this. And we've been given in the question that m is not equal to n, right? So this m minus n term, basically this term is not 0. So this is not equal to 0, okay? We can take that to the right hand side, and so we are going to be left with the term a plus m plus n minus 1 times d is equal to 0, right? Because this term is 0. This term is not 0. And what is this expression here? A plus m plus n minus 1 times d. So if you carefully look at this one and compare it, it's exactly our Tm plus n, right? Because Tm plus n is a plus m plus n minus 1 into d. So therefore we know that t m plus 1 is equal to 0, and that's exactly what we had to prove in this question. So the key thing is to solve these type of questions, just use the formula and write the term in terms of tm, tn, and what you're interested in, right? tm plus n. So we were on the lookout for that term, and we got it finally here, a plus m plus n minus 1 times d equal to 0, and so tm plus n is 0. Till now for arithmetic progressions, we've been using the formula of the nth term as tn equals a plus n minus 1 into d. Note, the nth term here is where you count n from the beginning, right? The terms are counted from the beginning of the arithmetic progression. But let's say you want the nth term from the end. So not from the start, we'll count the term numbers from the end. And we are interested in the nth term from the end. Then the formula becomes L minus n minus 1 into d. Okay, where L is the last term of the AP and d is again the common difference, and n is the nth term that you're interested in. Now an easy way to remember this formula is you compare the two formulas. Okay, so all you have to do is replace the first term A with the last term L, right? Because we are counting from the end, and you just have to change this plus into a minus. Okay, the rest of the part remains same, n minus 1 into d. So remember that easy way, just change the A to L and the plus to a minus, and you'll get the formula for the nth term from the end. I'm also going to be showing you a special trick where you can solve the sums just with this Tn formula, and you don't need to use the nth term from the end formula. So you can solve it just using the first formula. It's coming up. Are you ready for the next question? Here it is. Find the 8th term from the end of the AP, 7, 10, 13, all the way up to 184. So since we need to find the 8th term from the end, let's see if we can use the formula of the nth term from the end that we just learnt. Okay, so let's write down that formula, which was the nth term from the end, right? And what is that formula? The nth term from the end is L, the last term, minus, remember, there will be a minus there, and n minus 1 times d. Okay, so what is the last term in this AP? So that's pretty simple. The last term is 184. So let's substitute that here. 184 is our last term minus n minus 1. Now we want the 8th term. So n is going to be 8. So 8 minus 1 times the common difference. And what is the common difference here? So you subtract these two terms, 10 minus 7, the common difference is 3, right? And so if we calculate that, that's going to be 184 minus 21. So the nth term, the 8th term from the end is going to be 163. So that's our answer. The 8th term from the end. The 8th term from the end is 163. Okay. Now let me show you a special trick how to solve this question without using this formula. We are going to use our normal formula, the Tn equal to a plus n minus 1 into d. So we'll use the formula of the nth term from the beginning. So the trick of doing that is just take the series, the AP that you've been given, and just reverse it. Okay, so let's write the series in reverse here. So it's going to be 184, comma 13, comma 10, and 7, right? Now why are we reversing the series? Because we want to use the formula, the normal formula of the nth term from the beginning, right? So and that formula was a plus n minus 1 times d. Okay, and what is our first term here? Since we've reversed the series, this is the first term, right? A. So our first term is going to be 184. And we want to find the 8th term from the end. Okay, so for the reverse series, it's going to be the 8th term from the beginning, right? If you think about it, the 8th term from the end of the AP was what we wanted to find. Now, since we've reversed the series, it's going to be the 8th term from the beginning. So we can easily apply this formula. And n is going to be 8. So we are basically calculating T8, right? The 8th term from the beginning. And what is the common difference here? So the common difference, we need to subtract the terms, right? So it's going to be 7 minus 10, not 10 minus 7, right? You always take the next, this term minus the previous term. So the common difference is going to be minus 3 here. And if you solve that, can you see that? Are you getting the same thing? So 184 plus, and this is going to be a minus 21. So it's basically 184 minus 21, and the 8th term from the beginning of this series is 163. So can you see? We got exactly the same answer no matter which method we applied. So either if you're comfortable with this formula, nth term from the end, you can directly use it. L minus n minus 1 into d. So be careful, it's the last term and it has a minus sign. This formula has a plus sign. And then you substitute it and you'll get the 8th term from the end. Or if you want to use this technique, you just reverse the series and then it's a normal AP question, right? You use the first term and you just substitute n from the beginning and just take care to calculate the right common difference. So we can solve it just from the basic formula that we know. I have an interesting question for you. How many multiples of 4 lie between 10 and 250? Okay, so what do we need to find here? So between 10 and 250, so how many multiples are there of 4 are there between 10 and 250, right? So between these two numbers. Now one important thing to note here is, since they've asked between 10 and 250, we don't include the numbers 10 and 250. It's the numbers in between. But if it was from 10 to 250, then you include the numbers. Okay, so remember that in between 10 and 250, these two numbers are excluded. We don't include them. But if the question says from 10 to 250, then you need to include these numbers also. Okay, so how many multiples of 4 we need to find? So what are the multiples of 4? We know that 10 is not a multiple. So the first multiple of 4 is 12 here, 16, 20, right? And it's going to be all the way up to, will it be up to 250? No, because 250 is not a multiple of 4. So what is the last multiple of 4 here? 248. And even if 250 was a multiple of 4, since we need to find the numbers in between, we would have excluded it. So basically the numbers we are interested in are from 12 to 248, and these are the multiples of 4. So now can you see that these form an AP? So we have an AP here, right? Because as you can see, the common difference is 4. They are multiples of 4. So now what is the first term of this AP? As you can see, the first term is 12. So we have A equal to 12, right? And what is the common difference? Simple, 16 minus 12. The common difference as expected is 4 for the multiples of 4, right? And then this is our nth term in the AP, right? So our last term here is Tn is 248. And we need to find how many multiples. So what do we need to find here? We need to find n. How many multiples are there? So let's go ahead and use our formula. Tn equal to a plus n minus 1 times d, right? And so if we substitute, Tn is 248 equals 12 plus n minus 1. So we need to find n, that's our variable here, and d is 4. Okay, so you basically need to solve this equation for n, and if you solve it, you'll get n as 60. So that's our answer, that there are 60 multiples of 4 lying between 10 and 250. Now let's talk about an important point on how to select the terms in an AP. For example, let's say you're given that an AP has 3 terms. So what do you express the 3 terms as? You might be thinking A plus D, and A plus 2D. But let's talk about what's a more convenient way of expressing 3 terms in an AP. Okay, so you should actually use A minus D, A and A plus D. Instead of A plus D and A plus 2D, it's easier to use these terms, A minus D, A and A plus D. And can you see what is the common difference here? That's right, the common difference is D. But let's say you're given that 4 numbers are in AP. Then what do we take the 4 terms as? So when 4 numbers are in AP, we need to use A minus 3D, A minus D, A plus D and A plus 3D here. Okay, and what is the common difference in this case? Can you see that the common difference is 2D here? Okay, because if you subtract this term and the preceding one, the previous term, you will get a difference of 2D. And if you're given that 5 numbers are in AP, then what can we take? Then we are going to take the terms as A minus 2D, A minus D, A plus D, and the 5th term is A plus 2D. Now here the common difference again is, as you can see, D. Okay, so remember for the 3 terms the common difference was D. For the 4 terms it's 2D. Okay, and for the 5 terms it's D. So you can easily remember that because 4 is an even number, so the difference is 2D, an even number, right? And these ones are odd number of terms, 3 and 5, so their common difference is just D. Now let's look at an example to see why these type of terms are more convenient than taking A plus D, A plus 2D. So why should we take the terms as this? Let's take a look at the example. Here's our next question. The sum of first 3 terms of an AP is 48 if the product of first and second terms exceeds 4 times the third term by 12. Find the AP. Okay, so how do we solve this question? We've been given that the sum of the first 3 terms of an AP is 48. And remember, as we learnt, what is the convenient terms that we can take here for 3 terms? So rather than taking A plus D and A plus 2D, we're going to take these 3 as our first terms. A minus D, okay, A and A plus D. So let these be the first 3 terms of the AP. And since it says the sum of the terms is 48. So let's see what will the sum of the 3 terms be. So this plus this, right? So it's going to be A minus D plus A and plus A plus D. And the sum is given as 48. So now here you can see the D will cancel out, right? And so we'll have 3A equals 48. And so what is the value of A? It's 16. So can you see how convenient it was? Because we took these 3 as the first 3 terms, the D got cancelled out. We took A minus D, A and A plus D. And so it was very simple to solve for A. Okay. And now let's form the equation based on what's the other condition given to us. So it says that if the product of the first and second terms exceeds 4 times the third term by 12. So let's write that in symbol form here. So it's going to be the product of first and second term, so that's T1 and times T2, exceeds 4 times the third term, T3, so 4T3 by 12. So that's our other equation. Again, let's substitute the terms. So this is our first term, second term, and third term, right? So that's T1, T2, T3. So we can substitute T1 is going to be A minus D times A minus 4 times A plus D equals 12. And we already know the value of A, so let's use that. So we'll get 16 minus D times 16 minus 4 into 16 plus D equals 12. And if you solve this equation, you'll get the value of D. And that's going to turn out to be 9. Okay, so here we've solved for A and D. So it's very easy to find our AP now, right? So the first term of the AP is going to be A minus D, 16 minus 9. So our AP is going to turn out to be 16 minus 9, that's 7. And then you have the second term is A, so that's 16. And the third term is A plus D, 16 plus 9, 25, and so on. So we found our AP by solving these equations based on the conditions that were given to us. So the main trick is you look at the question and form the equations based on the condition, and here we use the trick that the first 3 terms were given. So rather than using A plus D and A plus 2D, we use this convenient form, A minus D, A and A plus D, and that made it really easy to solve this question. And so our AP turned out to be 7, 16, 25 and so on. And here's our final question. Divide 32 into 4 parts, which are the 4 terms of an AP, such that the product of the first and fourth terms is to the product of the second and the third terms as 7:15. I want you to try this question yourself, and do let me know your answer by putting it in the comments below. I look forward to reading your comments. So friends, I hope the concept of arithmetic progression is crystal clear to you now. There are also formulas to calculate the sum of the terms of an AP, but we'll discuss that in a separate video. And do remember to like, comment and share out this video with your friends. And if you haven't subscribed to my YouTube channel already, hit the subscribe button right now. Also click on the notification bell to get notified about new videos. You can check my Facebook page and do check out my website manochaacademy.com for the quiz and the top 3 questions on this video, and for more courses and videos for you. I'll put the links below. Thanks for watching.